Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have these problems. Maximize the number of target nodes after connecting trees. One. So this problem tags as a medium difficulty, and I feel so it's a medium. It's not that much hard. So there, if you are like familiar, so it's graph traversal algorithms or simple DFS BFS. If you know, then like more than 90% I am sure, like if you can find the question specific tweak, like if you are able to solve graph specific question like BFS DFS, then I am like on the path of to give you are a like kind of good coder at least. So on that case, that the tweak for this particular question we need, that question you will definitely need to identify by your own. Yeah, so we'll first understand the problem statement. So let's do that first. So what they have given, there exist two undirected trees with n and m nodes with distinct levels in the range of 0 to n minus 1 and 0 to m minus 1. So they are basically giving two trees altogether. One is from 0 to n minus 1, and one contains n nodes and another contains m nodes, and they are numbered from 0 to n minus 1. And you are given two 2D integer array ages 1 and ages 2 of length in n minus 1 and m minus 1 respectively, where ages 1 of I is EIBI, indicates that there is an age between node AI to BI and of the first tree, and ages 2, so blah blah blah, you can read it on your own. So they are basically given you the ages altogether of both the trees. The first tree they have given ages 1, and for second tree they have given ages 2, the list, so that we all know, all are familiar. But on this case, this is a undirected graph. So undirected graph means if you can grow from 0 to 1, then there is obviously a path from 1 to 0 also. So from 0 to 1, if there is a path, then from 1 to 0 there is also a path for sure. Now you are also given an integer k. So what this integer k actually signifies? This signifies that we will understand, and with this they have also given a integer k. So on the input you can see ages 1 of are given, so that is the first tree altogether they have given us. Ages 2 has given, so tree 2 given us, and k is given us. Now we have to do certain things. Now they are setting node u is target to node v if the number of ages on the path from u to v is less than or equals to k. Note that a node is always a target to itself. So they are basically giving a kind of like self edge, or a power of self edge is 0. So if you are not able to understand this line, so let me go to the one node. If it should work, man, should not give me dhoka, no? Yesterday it was giving. So what they have basically given us, am I able to write? Mostly, please give me right access. So if that is the node, and let's suppose there are 2, then let's suppose there are nodes 3, then from 3 to 5. So I am going to consider what's the terminology they have used here. Sorry, I missed it. So the terminology they have used to target node. So I can consider if should work first, no? Why it gone? It's too much lagging. So let's suppose if the k factors they have given us 2, so that means, and if I am standing at node 0, so that means from this node I can say all the nodes who are at 2 level far, who are at max 2 level far, I can consider they are in the boundary of the current node's target node. So what I am stating, I am stating from current node who all nodes are less than equals to k level apart, k level distance, I can say all of them are target nodes, of current node. I think this line should be straightforward, and you should get it, because that is what they have tried to explain but not able to definitely. So if I am standing at this node, so at max at level 2, so this node and this node they are at level 1, so these are at level 1, so they are obviously in the target node list. They are obviously a target node list of 0. This and this, how far? 1 2, how far? 1 2. So these are level 2. So that means all the nodes, who are those? 1 2 3 4 and itself. On the problems they have stated itself is also a target of itself. The current node is also a target of itself. So how many nodes? How many nodes? How many nodes? For 0 as a current node, how many nodes at 2 distance apart? There are all nodes 1, 2, 3, 4, 5. But let's consider if I am at node 5. If I am at node 5, how many are at max 2 levels apart? How many are at max 2 levels apart? So at these three definitely, these three definitely. What is the distance? What is the distance for these three? That is of level 1. That is of level 1 distance. Now this guy is at level 2. So this also is valid. This also is valid. Is this one is valid? Is this one is valid? 1, 2, 3. Nope. You are at level 3 distance, but I have the liberty to go to at max at 3 levels. So you are not my guy. Is it? Is 2 is? No. 1, 2, 3, 4. No matter if someone is not able to hit, so from its neighbors, so it's bound to not to get. So these are also all in non-boundary case, not able to do so. So for the 5 as a current node, how many we have found? The result is 3 only. 1, 2 and itself. 1, 2 and itself. But for node 0, we have itself, these all are. So I guess you guys are able to understand the lines, like significance of the lines. So let's go forward. Now they have basically asking us to return an array of n integers. So they are basically asking for return an array of n integers. Answer where answer I is the maximum possible, number of nodes target to node I of the first tree if you have to connect one node from the first tree to another node in the second tree. So I know their English is like in shit. You are not going to get it in the very first go, but I will obviously try my best to explain you in simpler term. So please skip these lines. We will do our sample test case iterations. You will definitely get the gist. So let's first do that. So I think we have pending with one line. So these lines let's understand. Just push these lines to your head only. I will explain. Obviously I will explain. So on node, they are basically given that queries are independent from each other. That is, for every query you will remove the added edge before proceeding to the next query. So they are basically giving one more things. So here basically they have basically asked for from the first tree, if you have to connect one node from the first tree to another node to the second tree to calculate the answer, what is the maximum possible, target, what is the maximum possible targets for the current node. So all the nodes we will consider from the tree 1 only. So here you can see return an array of n integers. N integers are n is pointing to first tree only, and is the maximum possible number of nodes target node I of the first tree. So on every answer we always have to give them. From the every node of the first tree, what is the maximum k factors you can, what is the maximum target you can achieve, for every node of the tree 1 only. And you have the allowance, you can connect any ith node of the first tree for which you are calculating to answer to any node, to any node of the second tree, to another node in the second tree, to any another node of the second tree. But for calculating purpose, you are eligible to create a node from tree 1 to tree 2, from node I of the first tree to any node of the second tree. But when you are calculate for node I plus 1 of the first tree, you have to omit it. I have tried my best to explain this way, but if still not you are going to get with the sample iterations, you will definitely get it. So that is the first tree they have given. So these are ages, these are blah blah blah. So this is the pictorials implementation, like pictorials view. Now we have to consider for every nodes of the tree 1, what is the maximum possible targets, right? And we have the powers when we are calculating, let's suppose for answer for this node 0, when we are calculating for the answer of node 0, we can connect this node 0 to any node of the second tree. So that liberty we have at, we can connect this to any node of the second tree, right? So let's utilize this. So what they have basically looked for now on explanations, on output you can see. So for node 0, so we all know our output list is bound to be equivalent to the number of nodes of the tree 1, So how many nodes in the tree 1? 0, 1, 2, 3, 4. So that means 5. So our output list is also of size 5. And what is the zeroth? What is the first number signifies? The first number is bound to signify from node 0 of the first tree. If you connect node 0 to any node of the second tree, what is the maximum target you can achieve? And target calculations we just saw in one node. So now let's go to the explanations part. So for I0, connect node 0 of the first tree and node 0 of the second tree. So we will make a connection from 0 to 0, this 0, and the k factor is 2. K factor is 2. So if we make a connections on this, and now we will start a level order traversal for sure, because we have to see level by level, because we have the liberty to go for at max of 2 levels, and on that maximum of 2 levels we have to find how many nodes we are able to visit, on both the trees, right? So if I am going to connect it this 0 to 0, then at level 1, who are those? 1, 2 and this level 0, right? There are 3 candidates, 1, 2, and if as there is a node, so this is also at one level apart. So 1, 2, 3 guys. Yes. At level 2, these 3 and 4 are bound to be, because 1, 2, 1, 2, and from here this one is first, and now from this we have the opportunity to go one level deeper. So on one level deeper, this 2, 3, 1, 2, 3, 1. So how many total now? This 0, the left tree is entire. No, the left tree is entire. From 0, the left tree is entire. What is the left tree entire contributions? 5. And on right tree, this 0 and its connected children. So 1, 2, 3, 4. So now 5 plus these 4s, 5 plus these 4s are 9. 5 plus these 4s are 9. Yes. Now go to the second. I will do for the first sample test case. You will definitely get the gist of the second one on your own. But maybe like of the 2 or 3 more, you will get the gist. Now we have the liberty to connect. We have to do for this node. For 1, they are basically asked for connect node 1 of the first tree to node 0 of the second tree. So same connections. So from 1, so these connections, that 0 to 0 connections we made, no? So that we have to remove when we are going to calculate for 1. So that's actually they have stated in node. So when we have the liberty to connect a node from 0 to 0 for a particular node, we also have to make sure that particular connections got deleted when we are going to calculate for second node. So now for this node 1 and 0 they have asked to connect. Now 2 distance, who are those? 1, 2, right? Only these two for itself. And for this 1, this 1 to 0 on single distance, and all of its neighbor. So on right tree, I think the contribution is same, 1, 2, 3, 4, and for itself, or for 0 we are getting all, but for here 1 distance, 2 distance. So how many? Only this 1, 2, 3, and here we have the same 4. So 4 plus 3 is 7. So that's the reason we are getting here 7. Now for this 2, I think at 2 distance, entire tree, and for this 2 they are basically asking for connect this 2 to 4, connect this 2 to this 4. And if we do so, so 1 distance this 4 and 2 distance all of its neighbors. So how many? 1, 2, 3, 4. This actually the star shape things. This actually the star shape, like opposite y, reverse y things. So how many? Right, tree 2 contribution 4, itself all 5. So 5 plus 4 is 9. Now for this 3, tree 1 contribution 1, 2, 1, 2. So 1, 2, 3, 4. Excluding this one, because this one is how far? 1, 2, 3, right? 1, 2, 3 far. So we can't consider this one. So we are going to consider 1, 2, and this one, because this is 1, 2, this is also 1, 2. So on left side contribution is 4, and on right side we are going to connect 3 to 4. Again this 4 connections, and this 4 is all like repeatedly going to contribute this reverse y, and on reverse y we are going to get 4 candidate. So 4 plus 4 is 8. Similarly you can do for this 4 also. You are going to connect this reverse y, and you are also going to, on right you are going to get 4, and on 3 ones you are going to get same. Only this 1 is going to be excluded, so 8. So that is the output you have to return. I think the problem is bound to be clear to you. There is no better explanations no one can do. So if not, then please I will suggest to go to one more iterations of the video, then you will definitely get it. Now we have to think on some kind of intuitions. So let's quickly take a look on the constant. So our constant is in the range of 1000. So n and m are all in the range of 1000, and AJSI to all are expected, and k factors are in the range of also 1000. Yes, this point, take a note on this. So our n and m can grow as big as 1000 only. Yes, we take a note. Now go to our favorite one note. So now I'm not sure you guys has already observed this beauty, but if not, then let me explore. Let me bring it to your eye first. So on tree 2. So for on tree 2, can I say I always have to connect, because on tree 1, no, what we are doing from tree 1s of any node, any arbitrary node, we are going to connect to to any of a candidate of tree 2, any of the candidates of tree 2, right? That we are doing. So can I say my tree 2 contributions is always going to be identical? Can I say my tree 2 contributions is always same? And what is the like greedy? If I am super greedy, then I know I have to connect to what? So if let's suppose I have a node in kind of like star pattern only on tree 2. So which node I am going to which node? So if let's suppose that is any arbitrary node 1 on tree 1, node 1 of tree 1. Then which node I am going to connect it? Am I going to connect it to this? No, because that is already a child node. No, that is already a child node. So from child, if you are going to connect it to the child node, then already you are lagging with some of the levels. Because you have to go from child to some upper leaf. So you are at leaf and you have to go some upper leaves. Rather than if I am going to make a connections here, and if I have a k factors of 2, then I can visit all of them. So let's suppose here also I have k factors, I can use 2. So 1 I have already utilized to make a connections, and from here I can only go to this orchestrator. But if I am going to make these connections, then from this I can go to this all are at level 2 distance, Yes. So I am able to make our tree 2 entire tree 2 contributions to my target, and that's what we have looking for. We have to increase our answer to be maximum. So one thing's for sure. I am looking for some centralized node, right? So on tree 2, that is the first observation. So on tree 2, answer is contributions to my answer is always constant. Yes, for tree 2, answer / contributions is always constant. And the second factor is we just saw we should be greedy to connect always center node, right? Always center node. Yes, always to the center or the orchestrator node, from where maximum branching has happened. So we always be that much greedy. We always have that much greedy. So now this point is altogether like kind of less important. If we are able to calculate this one, then the point 2 is not altogether valid. So we just looking for what is the constant contributions of tree 2. Then we have done. So we know. I think I have drawn a tree 2 here. So I know I am going to contribute to the central node only. So there is an arbitrary node. There from some arbitrary node of tree 1, someone is going to connect with me, and these connections has already decreased my k factor. K is the maximum level I can expose, right? Maximum level I can expose from the current node. So from that current node to connect to at least to tree 2, to reach to tree 2, it's already utilized its power to 1, right? So now when I am looking for this node, how many I can, so for any node of tree 2, if I am looking for from this particular node, how far I can reach, what is the maximum target I can achieve? So on simplified terms, what is the maximum levels I can achieve? So to reach that maximum levels to all the nodes that is lying to my maximum levels boundary, so that all I am looking for, right? Agree? Yes, you are agreed. Yes. So now tell me one thing. So if I am at this particular node, and to reach this particular node, I have utilized my power to be 1. Then from this node, I can explore how many levels is nothing but k minus 1 level. That's it. Agree? Because 1 power I have already used here to reach it. So from this particular reached node of tree 2, tree 2, I have the opportunity to go for at least k minus 1 level deeper to k minus 1 level deeper. So for every node, so let's suppose this is one node. So from this node I can go. So all are at level 1. This one is at level 2 distance. So like this, let's suppose there are more rings. So like this I can go. So the last levels can go at k minus 1. So till to reach to k minus 1 levels, all the nodes to my path, including itself, is the contributions for this particular node. Now we can do for this node also, because we don't know what is the centralized node. So that is the problem, no? So we don't know what is the centralized node for this particular case. So we have to do the BFS or the level order traversal for every node. So we have validated for this node. Let's suppose we are able to make our target to be 7 nodes. Let's suppose we are able to make some achievements of 7 nodes visitations. Now from this node, let's suppose let's consider it's a leaf node altogether. So let's suppose its contributions is bound to be less than of its right, less than of its. The same things we will do. So we'll do the same things what we have done for this. We are going to check like this. We are going to check these like at from level k minus 1. We will do the same things. These are of level 1, then these are all level 2, these are all level 3. Like this we are going to check at, again for this, let's suppose at level k minus 1, what is the contributions for this node, and I definitely need max of those. So what I need, so if I have m nodes of tree 2, I will do what is the maximum explorations k minus, what is the summations of node, for every node, what is the summations of node till k minus 1 level every node can do, that we just saw, and we need maximum of those, right? We need maximum of those, right? Because we don't know what is the central node, no? So that's the problem actually, because if we know that is the central node, then we can directly do a level order traversal from that node to all of its k minus 1 level, to from that centralized node to its k minus 1th level, no? And we can do the summations of those. Then it's straightforward. But here we don't know what is the central or the orchestrator node, or the central node, that we don't know. So that's the reasons we have to trigger our BFS or level order traversal for every node of tree 2, for every node of tree 2. Yes, we definitely have to trigger a BFS or level order traversal for every node of tree 2, and to check what is the contributions it can do to those, or let's suppose I can write it to the contributions. What is the contributions it can do to go to its k minus 1th level, from that node to its k minus 1th levels, how many nodes it can explore, So I need basically max of those. So like this way I am able to calculate my point 1. And what is my point 1? Tree 2's contributions is constant, and the constant factors we will definitely get to do a level order traversal from the central node. But we don't have any central node. We don't know what is the central node of tree 2. So we have triggered BFS for every node of tree 2 to every node of tree 2, and we have take the maximum of those, and maximum contributions only can be done by the central node. And we have stored it to some variables. Let's suppose max contribute or contributions from tree 2, which is the constant. We have stored it. Yes, that is the first part, or one of the major part we have solved. So we have solved tree 2's contributions. So tree 2's contributions is nothing but the liberty you have to connect a single node of the particular node of tree 1s, for which you are basically building your answer. So what you are doing, so let's suppose it is your tree 1, no? So for if you are landing on this, if you are trying to build the answer for this particular node, you are basically connecting with some node of tree 2, and you are basically checking what is for itself. So this part is always going to be constant, because you have the liberty to connect to any node of tree 2, and you will be super greedy to connect to the central node, and we just prove, if you are going to connect to the central node to every times, your answer to be tree 2's contributions to be constant, because from this node you have the liberty to go to at max like this way, k minus 1th levels, and we have taken max of those. So if you are connect to always the central node, the tree 2, what is the maximum contributions the tree 2 can do just doing these connections that we have already calculated. So this part is done. This part is done actually for our case. Now we are only pending to current tree 1. So what is the contributions that tree 2 can do? Sorry, tree 1 can do. Standing at the current node. Standing at the current node, what is the contributions? This particular node, standing at the current node, what is the contributions tree 1 can do? Tree 1 can do. So we just need to calculate those. So for tree 1, I think you should be able to point your own. So for tree 1s, we have to do the same things, but rather than to go to k minus 1th levels, for tree 2 we are doing for k minus 1th levels. For tree 1s, we have to check at from this particular node at k distance, at k level far. Sorry, this will take time. Sorry. So basically for this, because it is a part of itself, no? It is a part of itself. So on if it is a tree 1 and if you are going to connect to some 1 to tree 2, then you have to utilize a path to connect to altogether tree 2. But we have already done for tree 2. So tree 2 is done. Now you are looking for who are at k levels far from me, who are at max of k levels far from me. So if I am giving to k as 2, then all these are also 2 levels, these are also 2 levels and itself. So all are at 2 levels far. So now we have just pending, if we are trying to calculate the answer for this particular node. So for tree 1, we have to do for all the nodes and dump this to a list and return it. So if I am trying to calculate the answer for this particular node, I know right side tree 2 contribution is constant, that we have done with. And for this particular node, we will definitely trigger a level order traversal. We will definitely trigger a level order traversal, and we will find who are at level k distance, which nodes are at level k distance. So level k distance nodes, right? So that is the contributions of tree 1's current node to at k level distance. And what is the answer then? What you can add to the answer? So this, let's suppose if I am considered this as a result, then for this result is for tree 1, and for tree 2 you already have that tree 2 contributions, that is constant, that we have already calculated. That is it. So we have to do for every node. So this is always going to be constant. So let's suppose this is coming as result 1, then this is coming as a result 2 plus tree 2 contribution. Then again we have result 3 plus tree 2 contribution. So like this list you just have to return. Yes guys, so the problem is as simple as that I am stating, but identifying like this intuitions like is kind of a tricky. But if you are solving the graph, then interviewer going to expect like you should be able to find this. So this is like based on the company's perspective. Like if you are targeting to some FAANG level top product based company, then expect it can be asked to an interview. So now we will do my own template code iteration. So please like be a little bit careful, because this template can be used to any level order or BFS kind of things. You can use the same template as it is. There should not be any changes. So initially n and m is not given to us. That is a problem for sure. So we have to calculate how we can do. So let's do it. Let's do that. So we definitely have to define two graphs. So I have initialized graph 1, graph 2, default dict of list, and n and m I have started with 0 and 0. And I am here basically building the graph 1. So for u v in ages 1, graph of u dot append v, graph 1 of v dot append u, because undirected, u to v there is an age, v to u there is an also an age. And I here see how I am finding how many nodes are there. So that is nothing but the maximum of the nodes that I am encountering. That is the nothing but the maximum of the nodes that I am encountering. So max of n uv. Like this way I am also able to find how many nodes are there in tree 1, how many nodes are there in tree 1. Similarly, same things I have done for tree 2. I have built my graph has built, m has also calculated. Now I am doing max result in tree 2. So this is the variables where we are basically stating that tree 2's contributions is constant, that we all know, and we are first trying to calculate this. What is the tree 1's contributions that we will contribute. So max result in tree 2 I have initialized with 0, and I am calling for every node of tree 2, because that we have just seen, right? We have just saw for every node of tree 2, because we don't know what is the centralized node, no? Because on tree 2, if they are giving that is the centralized node of tree 2, then we are very good. Then we don't have to do this for loop. At least we can directly call our helper to the targeted node, to the targeted. So on each we can directly pass the targeted node or the given node they have given us, because they can say us this is your centralized node. because from this only you can get maximum levels you can explore. With maximum levels you can explore, maximum node you can explore with minimum level, with to go to minimum depth. Yes, they have not given us a centralized node, so we have to found to all the nodes we are going to found who is actually the centralized node. And I am seeing here, you guys can see here on max result tree 2. So max result in tree 2, so that is nothing but the max contributions, the constant contributions of tree 2. I am storing it on these variables. That is nothing but max result in tree 2, that is already stored to the helper functions call. On helper functions call I have done standard level order traversal, standard BFS. So let me just quickly explain it to you. So that is my template. So please take a note. You are getting the template in for free for sure, and also the understanding, but please try to put this on your brain so that on any further question on level order traversal or BFS related, you can use the template and get an AC on a very quick go. So I have passed my graph. So I have passed my graph to here, and I have passed the node from which we have to start from. That is nothing but my each, that is the variables, and what is the current level. So now I am passing my current level to be 1 altogether, because to reach to tree 2 we already have to 1 levels far. 1 levels we have already used. That we are seeing, right? So that's the reason we are basically have to liberty to use k minus 1 levels. But for tree 1 we have the liberty to all k levels. But for tree 2, to reach to tree 2 we have used 1 level. So when we are landing at each node, the node that we are targeting to start the BFS, we have already current level is already 1 level, 1, not 0. We are already at level 1, like already 1 level we have traversed. I think CY is definitely get it. So graph, node and current levels all are landed on these functions. Now I am doing a standard visited has standard like BFS only, current level order traversal only I am doing. So let me just quickly explain each lines one by one to you. So visited I have defined, I have taken a queue and I have initialized to a DQ because I need a pop left to be done in big of 1. So DQ, that's the reasons we have repeatedly. If you are not interested to understand why DQ, then like we need a separate discussions for that. But I think I have already done it. So DQ basically allowing us to do a pop left in big of 1. So that's the reasons DQ. Now on Q we have append the current node that is coming to us, and we have marked this current node as a visited also, and we have initialized our result to be 0. And now we are doing standard level order traversal here. Let me just explain this also. While len of Q, if the current level that we are looking for is more than k, because we have the liberty to at max go to k level, right? At max go to k level. So we are more than k level. So you don't have the liberty to go further. What is the result you have calculated? Return it out. And if not, then give me the n. How many nodes you have that particular levels? How many nodes you have on that particular levels? I want to go for all of them, and all of them are bound to be less than or equals to k. So that's the reasons here the check is not performed. So this, when I am at this particular line, so that means this line is not executed. So the current level is smaller than or equals to k. Then can I consider all the nodes contributions of that particular level to my answer? Yes, I can. So I am adding to result plus equals to n. So how many nodes we have that particular levels is nothing but len of Q, because our Q is holding for a particular levels at a particular times all the nodes of that particular levels. All the nodes of that particular levels is holded by my Q only, and I have added to my answer. And now I am basically need to pop all of them and explore their neighbor. So now I have to pop all of them and need to explore their neighbor. So I am writing a for loop for underscoring range in all of them I am going to explore, and I am popping them. nd equals to q dot pop left. I have popped it. I am trying to explore its neighbor in graph of node. I am trying to explore its neighbor, and if the neighbor is not visited, then I am going to add it. I am going to add it to my q dot append neighbor, and I have marking it also visited, to visited. And after this for loop entire execution, so that means I have popped every ones from the current levels and pushed the unvisited ones to the next levels. Yes, I have popped every ones from the current levels and pushed the next ones of the next levels, the neighbors of the next levels. I have pushed them all, so I can increase the current level. So that means who are in my queue right now is the one more level apart. So I have increased my current levels count to be plus equals to 1. And finally I am returning my result also. So this basically executed. This line basically going to execute if let's suppose my k factors is very small. But there can be cases. Let's suppose they are given very big k. So like this, you can explore all the nodes. Then on that case, these conditions is never going to be encountered. So that's the reasons we definitely need a result return for sure outside of it. I think this is very straightforward, intuitive. So I have done to calculate from the current node what is, if I am at current levels, if that is my current levels, and if that is my current node, then what is the maximum k levels apart if I can go to all the nodes I can visit, to all the nodes I can visit. So this function is going to do my job, and that's I am doing here, calling my helper with graph to each and one. Yes, that's it. So my max result in tree 2 is ready. And now I have to do some things, that is I am initialize my answer, and now I have to do some things to my which one to my tree 1, right? On tree 1. Now on tree 1s I am iterating to every node of tree 1s, and I have to calculate what is the contributions for that particular node to that particular node to my answer, from that particular node to my answer. So I am doing answer.append. Now tell me guys, what is the contributions of tree 2? It's already stored in max result tree 2. Agree? Definitely agree. Yes. It's already stored in max result tree 2. So I am doing a plus of max result of tree 2. So tree 2s, so that means the connections we are making, from these connections, that is the result extra result you are going to get. That is the extra result you are going to get. Now for the current tree ones, what is the contributions? If you guys are, I am pretty sure you should be tell on your own. Can I use the same helper functions? Yes. What's the parameters I need to change? Rather than graph 2, I have to pass now graph 1. Each factor should be each only. And what is the current level? As I am standing on the current tree only, tree 1 only, I am not going to connect to tree 2. So that's the reasons here I have used to current level to be 1 to start the BFS altogether, because the connections is going to utilize one level. But here I am standing already in tree 1. So I can start with current level to be 0, and every rest things would work as it is. No change, and finally I can return my answer. So I think you should see the beauty how I have reused the same helper functions for both the graphs with handling the labels in a smarter way. The smarter way we have put to handle the labels, so that same helper functions is reused across both the graphs and across both kind of level computations. Yes, that's the beauty we have introduced here. Now if we can quickly discuss the time complexity, I definitely suggest, like, it's not absolutely needed to me to explain, but I am doing so. So for every node, a node on this particular H tree 2, a particular node, how many times it's going to be visited? If there are m nodes on tree 2, and I am visiting every of them, how many times? M times. At very worst case, if my k factor is very high, and I am always going to execute this return of results. So that means I am triggering my helper functions for every node, every m nodes, and I am visiting all of them. I am visiting m out of m all of them. So for every each functions, this helper is going to visit all the m nodes. And how many times I am going to call these helper functions? M times. So m cross m, bound to be. I'm not considering these things like BFS kind of big of v plus e, because that is not going to be set for this. That is the maximum on big O terms. It is going to beat any of them. So it is bound to be a quadratic complexity, big of m cross n. And for graph 1 also, we are doing to n iterations, and we are calling our helper for every of them. So it is also big of n cross n plus, but it is a plus big of m cross m plus big of n cross n. So it is kind of 2 into big of m cross n kind of complexity, but that is the exact time complexity of this particular algo is bound to be. And this graph initializations, everything I am not going to consider, because that, so by default we have to use. And on space complexity also, I am writing it kind of big O only. So this graph is big of v plus e, but who is going to consuming more? So I am basically taking a visited and queue. It is going to store big of node, like big of n only, big of n or big of m only. And I'm not storing them. I am basically calling us new helper functions for every iterations, and it is going to initialize them on that particular time. This visited and queue is going to initialize to that particular time. So it is not going to store for every n iterations. It is not going to store all of them as a kind of data structure. It is like initialize everyone's, like memory flushing or garbage collections will be done after iterations of every for loop. After iterations of every for loop, this visited and queue is going to be redefined when I am going to on the next iteration. When I am going to on the next iteration. So that is going to be bound to be so. So it is not going to, we are going to spend a big of n cross n kind of space also. The space is, I have to say, is if you are considering big of v plus e for to adjacency list storage of a graph, adjacency list storage of a graph, that is it, and big of m you can write, or big of 2m you can write, big of 2m plus big of 2n. So it is on more general, I can write it is kind of big of v plus e only, because who is actually dominating? Big of v plus e, that is actually dominating, no? So the adjacency list representations of a graph, that is going to take the most space, that is going to take the most space. So yeah, I can write the space complexity as big of v plus e only. Yes guys, so and that is, I am able to think of the most optimized solutions, and that's the reasons I am pretty sure that that is bound to be a quadratic, that is bound to be a quadratic complexity, because here you can see, and you can see, like, that's the reasons they have given m and n as 100, m and n as 100. So that's the reasons you can trigger your level order traversal for every node, because that is the only opportunity we have at, because they don't provide us the central node, and without knowing the central node of tree 2, we have to trigger our BFS level order traversal for every node to find the central node, and for central node we know the maximum answer. Central node is going to contribute to the maximum answer, and that we are already storing, and it is bound to be the most optimized time and space complexity you can achieve for this particular node. And I know I have tried my best to explain this, but I know graph and DP, these are kind of like toughest topics, like on any interview perspective, and explaining this is kind of a very challenging for anyone. So I have tried my best to explain it to kind of in a almost 1 hour video, and if you guys are able to understand till this point, so I am requesting you guys repeatedly, please do subscribe to our channel, and please share the videos to your friends circle who are also preparing for top product based company and brushing up their DSS skills, and please turn on the notification so that when we are going to live to our next video, you will going to get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.